So thank you for being interested in managing EVM contract in Fabric. So this is a fairly new project. We haven't been officially released yet, but it's going to be very soon. And the whole purpose is to be able to support smart contract written in Solidity or Viper, basically everything that can be compiled into EVM bytecode, so that can be run in Fabric. Also, I want to first of all have a sign of hands. Like, how many of you are familiar with Ethereum? How many of you have been like writing contract or writing application or DApp in Ethereum? Okay, cool. And how many of you are familiar with Fabric or like have you at least tried Fabric? Okay, cool.
Oh, that's good.
That's nice because we kind of have assumed people will have some basic knowledge about Fabric. And okay, let's get started. This is Swetha Repakula from IBM United States, and I'm Jay from IBM China, and we are first several people working on this project. And the goal today is to let's go through some basics of Ethereum transactions, so people have a basic idea how that works. And we're going to learn how to install and invoke EvoCC, which basically is the runtime for Ethereum contract. And we will learn how to interact with this smart contract we just deployed in EvoCC with Fabric peer commands. So basically the one you use normally to interact with other Fabric contract. Also with Fab3, which is a proxy we developed to support the Ethereum JSON RPC APIs. So basically in Ethereum, most likely you will have the smart contract deployed in the network. Also, you will be interacting with that contract using Web3, which is a library developed by Ethereum that invokes those JSON RPC. We will go into some details later. And then we probably will group people into several teams, and basically they will reflect as several different organizations in Fabric network, and people will be deploying their own smart contract. And at the end of workshop, we hopefully can have several games running in this network, and people can interact with each other. Of course, we will be issuing our token. So basically, it's an ERC20 token. We will go into some details later, and people can play with that. And last but not least, we'll be hopefully having some fun. Okay, you want to do that? I just want to have a quick recap of how Fabric transaction works. So this is like very basic transaction workflow in Fabric. So first you have a client which sends the transactions to Fabric endorsing peers, where they collect the signatures on those transactions based on the endorsement policy, and you will collect all these proposal response and send them to the ordering service to have this transaction being totally ordered. And then the ordering service will distribute these transactions in blocks back to the committing peers, where these transactions, basically signed proposals, will be validated and eventually committed to the ledger. So this several steps will basically reflect the transaction workflow in Fabric. And some characteristics of Fabric, I just want to probably re-emphasize here. So we have this is a permission system. So you need to the chain code runs the transaction, and the output will be a read-write set. And based on the endorsement policy, different endorsing peer will sign the transaction. So this is part of the permission mechanism in Fabric. And all these components, they interact with each other using a certificate. So we know, like, we will be able to authenticate the counterparty. And currently Fabric supports basically Solo is for dev mode, and so currently Fabric supports Kafka-based consensus, and in the near future we will be having Raft-based consensus and probably a BFT after that. And in Fabric, we have this data isolation mechanism called channels. So basically, the channels is used in terms of to group organizations into its own shard. So you will basically join organization into channels, and they will be interacting with each other. Basically, will see the same data within that channel. So organization outside of the channel will not see the data. And we have finality for transactions, so it's not like, I think if you attend the keynote on the first day, basically for a lot of PO group school of consensus, we have probabilistic consensus. So basically, you will, after like certain blocks, you don't have the absolute guarantee that your transaction will be reverted, but it's very highly likely that it will be final in the transaction. But in Fabric, we have finality. So basically, once your transaction is in, it will be never reverted. We will basically run this workshop in several steps. First, we will help you to set up a local Fabric network on your laptop. So we kind of expect people have their own laptop working, and there are some prerequisites. First, you need to have Go 1.10 or plus, and Docker installed on your local machine. We're expecting Node 8.11.1. I think 8.9 should work.
Yeah, I think 8 point something.
Yeah, 8. At least it's the first long-term support of Node. And of course, we will need npm to install some Node packages. And
do people need a second to have get these installed, or are we all kind of on the same page?
And just since this is a workshop, we kind of expect people to ask questions whenever you meet one or you have some doubts. And we will go to the next step when probably all of the group or 60% of the group have finished the current step, and hopefully everybody can keep up with us. And we kind of want to make this casual, so it's not really a lecture or presentation. It's kind of a workshop, right?
Yeah. Feel free to tell us if we're going too fast, too. So I can give you guys a couple of minutes if you guys need to download these, or raise of hands, somebody has to download something, just so I have an idea. Okay, might maybe give you guys a couple minutes.
Oh, anybody has a
Okay, so I'm going to kind of move on to the next slide, but go ahead, keep downloading. There's going to be a part where we're going to kind of have to talk a little bit more, so you guys can always catch up. But for those of you who already have Go installed, or if you guys are new to Go, I just want to make sure we're all kind of starting off on the same page. So we want to set up our Go path. If you're familiar with Go projects, you probably already have this set up, but just make sure you have you want to first make a directory for all of our Hyperledger repos that we're going to download. So that's what the first command is. Usually the Go path that I use is home Go, but if that's different, switch out home Go with whatever your Go path is, and then make sure that both your Go path and your Go path bin have been exported properly. Otherwise, things just won't run.
When you install Go, do you install it under your home directory or under the user?
So when you actually install Go, it will be under your user or local bin. This Go path is what the Go binary or the Go thing knows how to use. So it's like a workspace that's meant just for Go projects. And Go expects this directory, basically. So it's not where Go is running from, it's just how Go knows how to run things. If that makes sense.
So the next thing that we kind of need to do is there's two main repos we're going to be playing with. The first one is the Fabric chain code EVM code. This is basically the repository that is keeping all the work that we are talking about that you guys are going to play with. It has the EVM chain code and the Fabric. So that's the first one. You have to make sure that it goes into your Go path the way we have. And then the second one is just a workshop repo that we've created for this. Yeah.
Do we have the slides to go? Or
Oh.
that'd be easier to copy and
Upload it. Do you want to upload it?
Yeah. Do you want to do it to GitHub or you can do it to the schedule?
If you can give people one URL where they can find the slides.
Yeah.
I'll just create it with no cost. People can, order.
Yeah, so if you guys all go to like the agenda, if you go and click on this, the first one on Friday, like if you go and manage, if you check on the talk, we can upload the slides there so that way everyone knows how to get there. And we don't have to pass around another URL. Yeah. So we're uploading it right now. So if you guys go to the agenda, you should see it. I can.
It's there.
So if you click on that first one, there should be slides over here. It is in a PowerPoint format, by the way.
Just right up hand, how many people are here with us? Like, completed the following steps. Okay, we'll probably wait for a couple more minutes. Yes, so these are the repos we're using for this workshop. Yeah, it's kind of we can expect workshop to. It's not really that sure.
Maybe another show of hands or people at this stage?
It's slow to download.
Okay.
To download the PDF,
Well, the repos too.
Even the PowerPoint takes a while to download.
Okay.
You have all the workshops competing with one another.
That's true.
Every day instead of downloading a bunch of things. So it's probably the worst part of the day from that point of view.
Do we have other things to download after this, or?
Start.
No, I think these are the big pieces. I mean, if you have Node Go already installed, then the rest of this is for the most part. But there's one more. There's like one more download we're going to do, but that's like later in. So hopefully we won't be competing for bandwidth. No, we're going to have to download some Docker images. I forgot. But we have a script for that, so I forget that you guys don't manually have to download each image, but...
Well, I think we probably should get people to start downloading Docker's image.
Okay, yeah, so since the slides are up, I'm going to kind of move a little bit so that way people who can move forward and we can kind of start to get through. So just for ease, so that way when we're doing things in the terminal and we know where to go, export these two, EVMCC and Workshop. It's just going to make it easier when we go back and forth between the two. Yeah. So just to kind of, so this is another step that we're going to download a lot of stuff. So if you can get here as quickly, I mean, you can't control that, but go to the workshop directory, and then we have a bootstrap script, which is basically going to download all the Fabric images that you need to run a local Fabric network for the first part. Yeah. I mean, basically, and then the next two steps, the BYFN, so we've borrowed the Fabric samples and we've altered it a little bit to make it easy for us to do the EVM installations and things. But then the next step is to generate the certs that you need to start up the network, and then the last one is to just run it.
Just how many of you have started downloading Docker images? Okay, this is probably the hardest part, despite downloading the slides. And while the image have been downloaded, let's probably go through some basics of Ethereum.
Yeah.
Okay.
Want me to do it?
So EVM basically stands for Ethereum Virtual Machine, and it's like JVM or other kind of VM. It's a runtime for a smart contract in Ethereum. And it's basically a Turing-complete stack machine, and all your code can be written in Solidity or Viper, and that will be compiled into this bytecode and loaded into EVM. And
Do you have a question? Is there a question? No? Oh, never mind, sorry.
false alert. But if you have any questions, just anytime, just stop us as well. And as we said, we will be using Solidity for this workshop, and there are another several concepts we want to mention for Ethereum. So there are accounts in Ethereum. Basically, you want to have, if you have some Ether, which is basically the token in Ethereum, and that will be stored under your account. But since we don't have such a concept in Fabric, so we don't really run Ether in Fabric. I just want to say that clear, that we will be able to run the Solidity smart contract. For example, we will be presenting some like voting app, or you can even issue the ERC20 token within the contract, but we don't inherently have token in Fabric. Therefore, we don't really need this user account. And there's another type of account in Ethereum, which is the contract account. Basically, the two types, again, user account, where as an individual user, can create a user account in Ethereum, which is basically the address will be extracted from your public key. And another type is contract account, which is the account to store the smart contract. And every time you want to invoke a contract, you are basically sending a transaction from a user account to that contract account. And of course, if you want to invoke another contract from your current contract, it will be a transaction from one contract account to another contract account. And all these accounts are associated with an address, which will be used to be interacted with. And again, in this work, basically in our EVM project, we will not provide tool to compile the Solidity into EVM bytecode, and we will be using Remix, which is a ID. Doesn't work at all. Look, 1, 2, 1, 2. No. Never mind. Basically, we will be using Remix, which is a web IDE where you can write smart contract, and it will compile the smart contract and deploy that smart contract for you to the Fabric network. We will be digging into that later. And when you call a contract in Ethereum, you're basically sending a transaction which contains a hash of that function name and the values encoded as the function arguments. And basically, you're sending all these long bytes to the contract account and to complete your function invocation, and we will be presenting it later. So just these are some like how basically the very basic ideas how contract invocation works in Ethereum.
Okay, so the other main thing is everything in Ethereum virtual machine is like a message. They've kind of consolidated all the transactions and the way anything runs using some of the message passing. So basically the format is this, to, from, input. Sometimes they might have other fields. But for what we are interested in, these are the three. And I'm just kind of going to go through, and this is a little bit going over Ethereum. This is not a Fabric thing. This is just so you guys kind of get a basic understanding of that world. So a regular transaction, how it's going to work is they're going to have a contract address. So that's basically the address for the contract account. So that's the to. The from is the account address. So that's who is sending the transaction. So in the Ethereum world, that can be a user account, or it could also be a contract account. And hopefully at the very end of this, we're going to try to see if you guys can also do contract-to-contract invocations. But for right now, that's what the from is. And then the input is usually going to be a function hash, which is what Jay was mentioning. It's basically how the EVM is able to know figure out what function it needs to call from a specific contract. And then there's a way that EVM encodes parameters. I'm not going to go too deep into all of this stuff, but this is kind of how the transaction breaks down. And you're going to kind of see how this translates into the Fabric world in a little bit. So there's special kind of a transaction, though. It's called a contract creation. This is how you create a contract account. And the thing that you do is you have to send the transaction to the 0 address because there is no account there. And the EVM, when it sees that, it's going to take the contract bytecode. That's what you're going to put in as your input. That's basically the compiled Solidity or Viper code, whatever you're trying to deploy. And then it will run it once, which will generate a runtime bytecode, and then it stores it under an account address or a contract account address. And that's usually, you can find it out later, how to get that information, and we'll show you. But this is what a contract creation transaction looks like. So how are we on downloading things and
Which version of Hyperledger Fabric you're using in your script?
1.3.
What version?
If you have 1.3 already downloaded, then skip that.
Yeah, because actually my environment was based on 1.1 and I tried to generate and was obviously failing.
So basically, the bootstrap script we presented before, that was to download 1.3, Fabric 1.3 Docker images.
yes, so if you already have those Docker images installed, you can kind of skip that and go straight into BYFN. Yeah.
We're gonna go back to the BYFN so we can
Go.
the setting. Yeah.
We're going to go back here.
Actually, I think it's safe to execute the bootstrap script because I do have the 1.3 images and just skipped the ones that
Yeah.
are already done.
Oh, sure.
Benefits of Docker. So just a show of hand, how many of you guys actually have a Fabric network running locally now? We got one? Okay. That's fine. Once we get past this step and we have the initial network, it's going to be a lot smoother sailing. How about the GitHub repos? Or people all downloaded those?
I mean, in the second part of this workshop, we will be targeting a already deployed Fabric network in the cloud. So hopefully that makes things much easier.
I had troubles with the path on the CryptoGen piece.
Yeah, so you're missing the bin directory in your path. The local workshop bin needs to
Right,
be
so
in the
this,
path.
I think the script, the
So-
BYFN script has a,
Yes.
Oh, yes, you're right, sorry.
And it's not BYFN, it's BYFN.sh.
Yes. Sorry. It's byfn.sh. Hopefully you guys caught that.
And so Bootstrap will have created a local bin directory with binaries that got downloaded. You need to have that in your platform. Bring your first network. That's what it stands for.
yeah, the script tries to set that up, I think. But I think it goes to then it's in a different direction. Or one directory up.
Yes, because there's a discrepancy between that.
Yes.
So you just add the local bin or you move bin up.
Yes, okay. When you guys finish that script, just kind of look locally quickly. Hopefully we'll have this all fixed up for tomorrow's if you want to come back. But in the meantime, just export that bin directory into your path. I'm sorry, this on my computer has already been installed into my bin.
So there's a, are you in a workshop, right?
Is there anyone confused about what just happened now?
Sorry.
No, that we needed that.
I'm trying it and I saw it.
I ran this.
Also, when you export the path, I have a slides back. You have the $sign.
Oh,
That
okay.
gives me an error.
Yeah, sorry. Okay. The $sign in the slides is just to indicate those are things you guys type. Do not type the $sign or do not copy that in.
I mean, just before you said, can you go a couple slides? Oh, yes, there should not be $sign. Yeah.
Oh, yes.
Okay,
That gave me an error.
thank you for doc footing this for us. And we will make changes in the flight.
Yes. After.
Hopefully providing a better user experience tomorrow.
Will
Yeah.
you be going to the same thing tomorrow?
Yes.
Yeah, I mean, as the
We can
conference
download
arranged.
things and be ready.
I mean, yeah.
Yes.
I was like kind of making a joke. You do not need to feel like you have to come back to this. I mean, there are other
No,
workshops,
it's exactly the same thing.
but if you would like to come back, yes.
Not exactly the same thing.
Okay, show of hands. Who has a network?
Can I just do Google instead of doing the Git clone thing? Would that work or no? If I did Google,
You can do a go get on the Fabric chain code EVM. You cannot do that on the EVM workshop repo because it's not a Go project. Yeah.
I will edit the slides.
Yeah. And then just upload. Okay, so as people are doing this, I'll kind of continue with our little bit of the learning part. And we briefly kind of covered this. So the first initial set of slides was just to kind of give you guys an overview of how transactions and smart contracts work in Ethereum, how do they work in Fabric, and what are the design decisions that we've kind of made. If you guys are familiar with the Hyperledger Burrow project, they have an EVM implementation. We have taken that, we've wrapped it around, and we're using that as a Go chain code. So what we're going to do is install the EVM as a chain code that will become kind of the home of all the Ethereum smart contracts. The way we're going to do this, if you're familiar with the Fabric chain code model, the interface that you have to do init and invoke, everything we're going to do, we're going to kind of consider it like how we do message passing. Those are going to be passed into the invoke. You're always going to call invoke, and you're going to follow that format of message passing. A couple of caveats that are going to be a little bit different from how contracts work in Ethereum is, Jay already mentioned, we do not have tokens. We're not introducing that as part of this work. But what that really means is you can't do user-to-user transactions. So there is nothing, you can't run a transaction that doesn't involve a contract, either contract creation or a contract invocation. And then the next thing is contracts must be deterministic. So for example, you can't have something that's like has an element of randomness, for example, because of the way the endorsement policy and the consensus is reached in Fabric. So that is different. So if you have Solidity contracts that kind of have like a random number generator, it's not going to work. Most likely it's not going to work. If it works, there's something wrong with your random number generator. So how are we on the network?
Still downloading.
Okay, we're now stuck because I cannot move forward until you guys have a network.
Is this crypto tool ontvangen?
Sorry?
Is it crypto tool?
Oh, okay, so,
Missing something.
so if you kind of just do an LS here, do you have a bin directory show up?
Yeah.
Okay, can you export that into your path?
Okay.
Just a question on what you just said here. Can you give more details on what does this means? No token, so there is no the concept of gas? Does it mean that gas is free in this context? Or?
Yeah, so there's a couple of things. So the question, if you guys are familiar with Ethereum, was when we say no tokens, how does that deal with gas? Which, if you're familiar with like how the virtual EVM actually works, the way it works is they have when you submit a transaction, you also give it an amount of gas. This is kind of like an intermediary asset token thing in Ethereum. Basically, you have to pay per opcode that runs in the Ethereum virtual machine. So if you run out of gas, your transaction immediately stops and you won't keep running opcodes. So gas is still an element of the EVM. It's just that there's no longer a need to pay per transaction or allocate it. We're hard coding it to a very high limit, so you should be able to successfully complete any transaction that you're going to run. But if people start having issues or there's feedback about making that configurable, we would like to hear that.
So basically, it's free to run the contract, but the gas is still there. But we set hard coded to a limit as the mean to make sure the contract terminates.
So what prevents me from running transactions in a contract? It just
But
what prevents me from running transactions? That is something that.
so there's
if gas is free, what prevents?
but there's still a gas limit, which currently is 90,000. So
Yeah, but then what prevents me from sending?
So I think that, the question you're asking is kind of the difference between Ethereum and Fabric. So the way the Fabric consensus is achieved, you have to get endorsements. You have to get other peers to sign your transaction before it even gets put into a block. So you can submit a transaction, and if it's malicious, the other peers have the option of rejecting that transaction. So the kind of mechanisms to keep malicious actors away is slightly different. Does that answer the...
Yeah. Let's say I have an ERC20 token that is implemented. I have my code in Solidity. Can I just compile it, put it in the EVM, multi-work, be able to transfer tokens from one token holder to the other? Or?
yeah. I mean that's what we're gonna do later.
Okay.
I mean you can deploy ERC20, but that's again ERC20 token. It's not Ethereum token. It's not Ether. It's just we don't have Ether, but basically we don't have built-in token. Yes, there's nothing preventing us from deploying ERC20 contract.
So I was just going to ask, I guess when you talk about no user, so in terms of why you would want to use this fabric, is the idea then that maybe this is better for that type of application where you have users who absolutely don't know each other, and so that concept of the benefit of the blockchain is like trying to validate things where there's people who have absolutely no connection to each other. Again, I'm looking at this more from a business perspective. Why do I care?
Okay, so I think this comes to the question like why, from the very beginning, why do we do this from the beginning? So basically, for Ethereum, there are, I would say, a huge ecosystem, like all the toolings around Ethereum developer tools. And some people, or not many probably, think Solidity or Viper are more business developer friendly. So basically, they don't really want to program in Go or Java, but they think Solidity, this kind of contract-oriented languages are more natural to them. And we want to be able to provide this developer experience to these group of people, so they can, if either you already have a application in Ethereum and you want to migrate that to Fabric, so basically adding a permission layer to that application, or you are just more familiar with those toolings. And by the way, the Remix, I personally think is a pretty good IDE, and they are many more like MetaMask and Truffle, all these frameworks for Ethereum. So basically, instantly, once we support this smart contract in Ethereum, we can gain the benefit of leveraging those toolings. So that's the very basic idea of why we're doing this project. So, but still, since we're adding permission to basically in Fabric there are permission, and then as you said, we expect users to be authenticated and they will be using a certificate to interact with the network. It's not like in Ethereum you can just add an arbitrary user or individual, you can just send transactions. So we are still expecting people to be using their known certificate or be belonging to a certain organization.
One other clarification. When I say no user-to-user transactions, I'm talking very specifically about, like, say I want to give you 10 tokens or 10 Ether. Those kind of transactions are not supported. But if you and me interact through a contract, that's totally, that works. That's still there. So that's the distinction. What I mean is there's no smart contract involved in those transactions. Those kind of things we're not supporting.
Okay, how far are we with a locally running network? Does it work?
The network is still
Oh, it's still downloading?
Yeah.
Okay.
Okay, how many people actually have a network running though, so I can see if it's even worth moving forward?
Okay. Somehow it should work. Just wait for a while, but we can. Do you have the slides?
for the last week.
Okay, so while we're waiting, we might just kind of give you guys a little more of a technical overview into the work, because we have the time and we can dive into some of the details and some of the questions. Actually, I think it would get answered.
I just have a question. So this network that we are
For reporting purposes.
okay. So this network that we are creating, is it going to be a network only on my local machine, or will it be a network in which we all are going to be part of? Like every one of us is in it? Is it like that, or is it I just have 4 to 5 nodes on mine?
So for now, so the first part of the workshop, you'll be running with your local network only, so you're not interacting with other people, but we have a cluster deployed in the cloud, and for you basically beforehand, and we will be interacting with each other using that network. And you can definitely just join your local peer to that network. It's definitely possible. Just we think, we just already deploy several of them in the cloud, so it's easier for people to interact with the contract.
Like, will it be possible? Means because most of the attendants in this workshop are on the same network, so there's no NAT or other issues. So
Yeah,
is it possible to have a purely distributed thing instead of connecting to some centralized cloud thing?
It is possible. It is possible. Just, it's definitely possible to everybody will run a local peer in this local network and probably have a order service somewhere, and so we start interacting with each other. But that's not part of this workshop. It's probably part of another workshop next door, where the purpose is to interact with EVM.
We're also downloading Fabric images from.
What?
It's a Fabric.
They're probably downloading
Yeah.
yes.
Okay, so these slides are not meant for the workshop. They're slides that we use when we give a technical version of this. Some of it we've already said, some of it doesn't quite apply, and I might skip over, but we can kind of go through. So we already did the overview of Hyperledger Fabric. So basically the idea is we'll talk a little bit about Fabric, we can talk about some of the motivations of why we're doing this work, then we'll talk about EDM concepts and then the actual implementation. I'm not going to be doing a demo, you guys will be doing the demo later on, so hopefully it'll all make sense. As you'll start noticing that these slides look similar to what we already have in the workshop. But basically, permissioned, endorsement policy, finality, we talked about that. I take that diagram that is in there, and this is kind of a little bit more animated to explain, and this might help some of the confusion about the Ethereum to Fabric transfer. So this transaction flow is not changing. The way it works is you're going to have a user client, right? If they want to invoke or have any kind of transaction, we already have chain codes installed on the peers, and we have an ordering service there. The first thing the client has to do is they have to go collect the endorsements from these peers. Once they get enough endorsements, then that means they're allowed to submit their transaction. So they're going to broadcast it to the ordering service, and then the ordering service is going to create a block with that transaction in it. Actually, let me go one step back. When you collect the endorsements, what you're actually getting is these peers. That's the execute stage. That's when the actual smart contract is being run in Fabric. And what it generates is a read set and a write set. So it says this contract, this is the data that it read, and this is the data that it's writing to. And it collects all that information, and it passes it back to the client. So the first thing the client has to do is the read set and write sets should match with each other. I mean, if it doesn't, you're going to have a problem, and that transaction is going to be marked invalid. So once you get enough endorsements and you get the same kind of response back from all of them, you can send it to the ordering service. The ordering service is going to make a block, and then it's going to deliver it to the peers. Now, the peers at this stage, they're not going to run the transaction again, because when they get the information, they're going to have a read set and a write set with the information, and all they do is they verify that the read set hasn't changed. If the read set has changed, then that means something has changed since the transaction was initially executed, and it will always put the transaction in the block. The block will be written, but it'll be marked as invalid, saying that the state has not been changed by this transaction. This read set, write set thing is the reason why the contracts that you deploy in Ethereum have to be deterministic, because these nodes are running them simultaneously by themselves, and if there's some kind of chance of randomness, they're not going to be able to come out to the same answer, and if they're not, your read sets are going to be different. Yes?
The contracts will typically generate them by writing some Solidity code. So by definition, they will be deterministic, right?
No, not necessarily. Like if you have like a random number generator, right, in the contract itself, peer 1 will get 5, peer 2 will get 10.
But if I'm using Solidity, there is no way I can write some non-deterministic code.
It's dependent on your policy, no?
Sorry?
It's dependent on your policy. If your policy is only one peer from all the networks, then you can't do like some indeterministic code.
Yes, to an extent.
And back to that question, yes, that's accurate. And to policy, I don't really get why policy prevents you from writing.
Because if you say your client to send on you, the policy of the chain code would be.
Oh, I see what you're saying. Okay, so if the policy is that you have to only get one signed endorsement, right? Only one peer has to do it. You can have indeterministic code because only one person has to validate it. I'm not sure how practical it is to have a network like that, but yes, that is true. There is a way to do if you want to have an indeterministic contract, and that applies to everything. That's not just Solidity. I'm just talking about the chain code kind of a thing. So we kind of have, this is our transaction flow, right? And the only thing we're going to change in all of this is instead of having chain codes, what about if we have an EVM running on these peers? And that's kind of the goal of the work, to be able to do that. And the reason is so that way we can also leverage some of the tools that are out there, because the Ethereum ecosystem has a lot more. If we can use some of it, it'll be kind of nice and kind of bring some of that developer experience that people enjoy into Fabric. So we kind of already went through some of these motivations, but basically it's to enable people who are familiar with Solidity and Viper be able to write contracts on Fabric and not have to learn Go or Node. Also, the other thing is we want to have a migration path for those who, they've already developed and invested time in learning and creating these assets on Ethereum, but if they feel like they want to move to a permission setting, we want to give them a migration path so they can reuse some of the work that they've already done. We also want people to be able, again, the tooling, so all these tools that Ethereum uses, they're based on the expectation that these clients implement the Ethereum, or the clients expect that whatever it's talking to implements the Ethereum JSON RPC API. So once you implement those, and the more and more instruction sets you get, you kind of open up the tools that you're allowed to use. And then the last thing is the Burrow EVM is Apache 2.0 license, so it was easy for us to pull it in to Fabric. So some of the EDM concepts, we've already kind of talked about these. We have accounts, which there's external, they're called externally owned accounts, EOAs, they're user accounts, and there's contract accounts. Gas, that was like one of the questions. We still have gas, it's just that it's not configurable. We give you a hard-coded high limit, so any transaction you want to run should run successfully to completion. We talked about EVM message calls. Basically, it's a to, from, input. Those are the three main parts of the message that you have to pass in, and we're still going to keep that. This read current transaction rights, and this is a little more of a technical detail. In Fabric right now, when you have a contract and you read a value, then you write a value, and then you read out the same value, you are not going to get the value that you just wrote. So as an example, if you read the value A, and you get 5 back, and then you write A equals 7, and then you read in the same transaction, it's going to still say 5. And that's just because of how the ledger, and mostly because when you execute, you're not actually altering ledger state at that moment. In Ethereum, that doesn't work so well. So what we have done is we've implemented a little cache around the Ethereum. So that way, if you read a value or you write it, we kind of cache it. So that way, when you write something, we first look in the cache, give you that value back. So that way, you could do some read writes and kind of they could be connected to each other. And then we already talked about the Ethereum JSON RPC API. So the design, we basically have two pieces. We have the EVM chain code, so that's the actual piece that will be running on the peer nodes. That's where the EVM is going to be. And that's just the runtime aspect of it. That's how you run the transactions, all of that. The second piece is Fab Proxy. Since these slides have been created, we are changing this to Fab 3. So you'll start seeing the documentation start saying Fab 3 instead of Fab Proxy. But basically, it's an implementation of that API that we mentioned, and it opens up tools like Remix. We're hoping to get Truffle support soon, but we have Remix, Web3, and those are the tools we're going to play with today to deploy and interact with the contracts that you deploy on Fabric, which is a slightly different, that's different from how usually you would interact with smart contracts on Fabric. So we're kind of enabling a new way of talking to the contracts. So this is our implementation. We have two pieces here. Again, as I said, we have Fab 3 on the left. We have a peer, which is an example peer. Basically, if we go through how a transaction would come, we expect that it'll hit the API. We're using the Go SDK to be able to actually communicate with Fabric. It's going to invoke the EvoCC. Once it invokes the CC, we have implemented something called the state writer. Basically, it's a layer so that way the Burrow code can talk or interact with the Fabric ledger. It's just like an intermediary state. And then state writer will usually get the contract code, so that this is different from how Fabric does things. Fabric, you have to off-chain, you have to all install the chain code on all the nodes. So if you have many different organizations and stuff, all the admins have to kind of do it simultaneously. And then you do an instantiate, that's a transaction. And the contract code, when you do it in Fabric, is actually staying in the peer file system. For the EVM smart contracts, the contract code is going to be on the ledger. We're actually committing it into the ledger, and you're not going to go through the install instantiate process as you do in Fabric. And that's mostly because the install instantiate applies to the EVCC, not the smart contracts that you deploy through it. And then the rest of it is just generating reads and writes. And this is usually where I do a demo. But let's see, where are your local networks?
I just have a question regarding this presentation you gave. You said about you maintain a local cache in the you have made a select modification to how contracts would work on Ethereum. So isn't it the aim that if I've written a Solidity contract and I deploy it on Ethereum, and if I deploy it on Hyperledger, it should still give you the same results? Yeah,
the cache won't affect. The cache is in a way to help that happen.
But your the external transparency kind of diminishes because of an internal change in variable. So, for example, in EVM, if the value of the variable changes, it will get recorded on the block and then the next change will happen. In this case, there is a change which is not being recorded on the block.
No, that's not quite it. So even in Solidity, it's considered one transaction, right? It's one transaction in the block, and it's going to say this value changed from here to this.
Okay.
And that's the same thing that's going to happen here. We're talking about within that transaction execution, if you're doing this read. So even in Solidity, if you do the read A, write A, read A, it's all, in the end, it's going to be, you wrote A to this value. That's all that's going to be recorded, I believe. Actually, when you look at a transaction, the way it works is it's just kind of giving you what has changed, right? And you'll have all the arguments that went in. So you can recreate the transaction if you want, and you'll still have that ability on Fabric. You can see it, you can do it yourself.
It's basically just read your own write kind of semantic we provide here. I mean, sometimes we want to do that in Fabric, like your normal chain code as well. It's just a semantic we provide for Solidity's contract. Okay, so let's see how many of you have the locally running network? Here's a hand. Okay, I think we can proceed.
Okay, so we're going to start moving forward, and hopefully the rest, the internet bandwidth frees up, and the rest of you guys can catch up. So the next step, we're going to install the EVM-CC. So some of this is going to make you guys do a lot of typing, and some of it will be easy script running. So first thing we're going to do is we're going to exec into the CLI container that you've created through the local network. One thing that we've already done, so if you compare this to the first network Fabric samples example and you look at what the differences are, the thing is we just mounted the Fabric chain code EVM repo into those containers. And the only reason we can do it is because we set up the Go path, so that kind of explains why we're making you do these steps. So raise of hands when you guys get to that prompt. Okay, not bad. So the next step, we're going to actually install the EVM. So as I was mentioning before, this is this thing where each peer has to get the installation by itself. It's not like a transaction you can submit. So what I have provided is a script in the scriptster. So when you, in your CLI, when you get to that terminal, you should see a scriptster. And in there should be a target peer. The first argument that you put in is the org you want to target, and the second argument is the peer you want to target. So there should be 4 peers distributed on 2 orgs. So and then the peers are numbered from 0 index. So you have peer 0 and peer 1. So the first thing you want to do is scripts target peer.sh10, so that way it sets up the environment variable so the CLI tools know the CLI knows what peer to talk to, basically. And then the next step is to peer chain code install it. We're going to just call it version 1.0. It really doesn't matter if you want to change that. Just remember what you put. It's a Golang chain code. You want to name it the EVM-CC. This is not a hard rule that you have to install it as the EVM-CC, but it just makes things easier. And if you follow this practice, a lot of the tutorials and things like that will be easy to kind of follow. And then the path, github.com, Hyperledger, Fabric chain code, EVM, EVM-CC. So once you do it the first time, I'm going to make you guys do it manually the first time. Then we gave you a script to install it on the rest of the peers, so you don't have to type that out again. But that script will not install it on that first peer that I am asking you guys to target.
So you just run that first 2 commands on the first peer, then run the bottom command for the rest?
Mm-hmm.
Got it.
Yeah. Oh, also for those of you who have downloaded the PowerPoint, and if you're doing copy paste, just be aware some of the hyphens might have some of the PowerPoint kind of encoded things. I tried to catch as many of them as I could, but I probably missed a few, and as I look through the slides, I can see things that I think will be a problem. So if you see quotations that are slanted, you're gonna have a problem with those, and then if you see dashes that look a little longer than what they should look like, you're gonna have a problem.
And the backslash also gets in the way.
Yeah.
Yes, see, we meant for you guys to type this out. So how many people have the EVM installed? Okay, I'll give you guys a couple more minutes.
Well,
It's giving you an error?
here. Yeah. It says. It's like me, right? Yes. Yeah. Just set this and do. You can do UI
Okay, can we try something a little bit different? So that target script, I think it installed mine on, this is the first one. Yeah. So you have include installed on peer 1 org 1, peer 0 org 2, fail on peer 1 org 1. So is that target script? One more else? Yeah. And then you're gonna the other two more.
order and fabric is cluster.
And then run, yeah, just
The order, the blocks that actually takes the block.
so this is broken. You might have to make you redo this.
All the order does is cast in the block. So he sets the order so that these actions are being submitted.
So if you compare dash dash.
Well, this was here. In Fabric, we divided
This is already installed.
This is
Not sure why, but it's the next step carries out. We can move on a little bit further. I think that's those areas.
Okay.
the ordering doesn't care about the nature of the transaction, it just orders the transaction.
Where's the credit?
Where is it? The tool or the search? Oh, so the tool, whenever you ran
It's collecting, it's submitting the transaction, and it collects the endorsement to then submit.
no, not Slashware, the bin inside of the EDM workshop. We thought there should be a bin in there, and that's the bin you needed to export.
Here, go on starting here.
But you interact with the network through some place.
I mean, if you don't know the goal lines, it still works. I think that's the.
Is this on my local machine? Does it work?
This is mounted.
So everybody in the organization can run one of your it's just that we've separated in class traditional blockchain architecture.
How are people doing on the installation?
Extracted that part of the
Okay.
resources from the peer. It's they're similar.
So those of you guys who are still working on this, can I just switch to the next slide so we can do the next step? I think so. Okay. I can always go back if you get confused. So now the next thing is we need to instantiate. At this point, whatever peer you're targeted should be fine. And I have given a script to export the order CA so that way you don't have to type that file path out every time you do a transaction. And basically it's going, and you have to source it, don't run it, source it. It's just doing an export command, and it's setting the orderer _ CA environment variable. And then you're going to run the peer chain code instantiate. And the channel that should have been created when you created the network is my channel. We installed it as version 1.0, so make sure you do v1.0. And then the constructor args, these are the arguments for the init command of the EVM. The EVM init doesn't really do anything, doesn't need to. So we're going to pass in no args. But this is one where if you're copy pasting, you might have to rewrite the quotes, the single and the double, because they're slanted. Then you want to say the EVMCC, pass in the CA file, TLS true, and then target the orderer, which should be at orderer.example.com, port 7050.
So is this like a direct use on the local file system, or is it trying to bring it
Should be a
top amount?
Should be a 5 amount. 5 amount.
By
From your local post to the
Then I can.
I mean, you can, if you change the
So I will
compose space.
Yeah. Which file? The compose.
This can be closed. Permission to directory.
Oh no, it doesn't have that function. It's not that function.
But it's not on my electricity either. I think
Mine is not.
but this is
I mean, they come from different teams that make different technical choices.
yes.
So I'm not sure.
They all have different characters.
I'm sure there must be some thing that has been used. So let me just instead of doing
I think the reason that we can consider is because
so can I use that dot .py as a print out
it's
the
the plus that there's a lot more activity around Fabric than
Show of hands, how many people have instantiated the EVM? How many people have installed it? Is it the same people? Okay. How many people are still waiting on the network? Let's figure out where people are stuck at. Okay, so except for here, does everyone else have a network running? Okay, almost. Okay. I'll take that almost as a win. You know, we're getting there. Once you get the network, we've done half. The hard part is kind of done. Okay, I'll give you guys maybe a couple more minutes. So there is supposed to be a break in about 20 minutes. So hopefully we can kind of get this initial part done. I'm going to make you guys deal with bytecode and deal with the kind of grit of Ethereum virtual machine, and then you're going to find the beauty in using Remix and some of the other tools, and why Ethereum has all these tools, because nobody wants to touch bytecode. Yeah. Can you open up your terminal? And in there, we do Docker ES dash
So,
sorry. And then in there, can you take the peer or the associated word to do the one right button?
and so this is what we do.
And then I want to do Docker logs dash f. So maybe just see if there's an error one.
Well, if it's the same application, it better be the same. But you can have different changes because you can have more than one application, or they can be different, even the same application can have several changes.
Maybe try the other word too.
Yes. Yeah, and cheat codes can be called from one another.
Channel, my channel.
When you're in the cheat code, you can call another cheat code. It's limited to read, but you can.
Somehow your
So
peer
you can
did
do
not
your
successfully join. Can you do no, it would happen when you did the up. Yeah, the last one. That's the one that went wrong, but you're not going to be able to run that again. So go back into the terminal that you're execing to do CLI. Okay, and then you ls just so I verify where we are. Okay. On under the scripts.
Yeah. It's permission.
Just runs out. Some of it will fail and there's errors, and hopefully goes to completion.
They don't write directly, they write some change transactions. It's not the order. The order is the peers. The order only decides on the transaction order that you block, but it sends to the peers. It's the peers when they receive the block, they write it to the ledger.
I'm not sure what unfortunately, I would bring the network down. I'm downloading everything, it should be faster. I can also help you debug once you get
It's in Docker. You kind of find a checker. So you know Docker.
Packages them into a block, and then it sends it to the peers that every single block and write it.
That package says it doesn't exist.
We got spear1.org.com,
Yeah.
but that is just why I have the information. So this is where you're saying it was hit.
And you're using.
No, but then I should be able to see it.
Where did you use keep on the
So this one is going to be there now. Okay.
I think so.
Yeah.
The different mechanisms, but
Yes, that first one.
Yeah, but because this is the name of the volume.
On your, yeah.
When you get right down, it deletes the volumes.
all the other peers.
No, so I brought it down and then I brought up again after the creating. So first, because you said it was binding to the local file system, I actually created two files and tried to make it again. But then it failed again. So then I started change all this, but then now what I do is
Yeah, it's just like, we created the thing, but there's no, that's yeah, sorry. Yeah, it's to me, it's like you have the Genesis block, the channel block. And the peer, one of the peers can get added into the channel. I'm not 100% sure where the error is coming from. So you have to do a VY FM down first, so it brings down. And then before you redo everything.
Probably just create a local
okay, so
that for
okay, so let me do one final thing in which I delete all my algorithms manually and
That's sure.
Yeah.
Okay, that's fine. I just want to verify that.
I can read.
Yeah, try bringing it up again. There might have been some errors in the network.
let me just check up.
Just about it.
The what? Do generate and then do up.
Is it proof right now? Is it proof?
We have 10 minutes before the break.
We should look at it. Try to have people instantiate checkout before we break.
Yeah, okay, so we're gonna try to make this the goal. If you've already gotten to the instantiation, I mean, we're gonna try to get this done before the break. So if you're already there, I guess feel free to go to the break early if you'd like. But how many people are still at the network layer, getting the network up? Just one. Two, okay. Not bad. We can also help, oh, 3? With CryptoGen, is it that I can't find the tool? So when you do the bootstrap, we missed this step in the slides, but when you do that, you should see in the EVM workshop repo, there should be a new directory that gets created called bin. In that bin, you have to export that or add that to your path, and then the rest of the generation should work.
How many people have already instantiated the EMCC chain node? You're free to go.
Swetha. You could change the bootstrap version. It actually has the path in it at the top, but it has ///// and then some. So that's not safe. You do that in your own version, so when people clone, they get that version.
Yeah.
Now you have to explain one more step of saying the path. Yes.
Oh, no.
Already happening.
I thought about that. I understand because the first have all sorts of shit, but just say, make sure if you have any fabric container ready, take everything out and clean up. Yeah, well, then the second container.
It's all in the environment. Or then you run
Don't want to run like this, they download the game and say it's correct.
You're right, sorry. Yes. Well, yeah, and then if you guys don't have errors, then feel free to go into the break and try to debug.
I already instantiated.
Perfect. Yeah.
Are there people who are stuck or running into errors that we can try to help If I haven't seen you, raise your hand.
Yes, so I did this less successful, so I've done this with the other here.
You should do that one still live.
Oh, sorry.
He's having a problem because the network isn't fast. When you created the BYFN, were there any errors or anything stuff? Nothing? If you have the output, if you can find the output, if you I mean, you can run the manual error out now.
No, when I copy the command from here, and then I echo it.
Are you looking for the command? BYF.se. Yeah, but don't run it again. It's going to fail now if you have the output. Because what? Everything's good. So the only, when I've seen this error, it's very strange because we hard-coded that network and the course off. But if you didn't create it in your container structure, yes. No. Yeah.
He's having some problems.
You have to. If it tells me the BYFN script, and it goes successfully, and then you might have to clear whatever networks are already.
I mean, the thing is, the network name is the direction name.
I changed it. Yeah.
But if people are running, is it possible if people are running the script from another direction?
No, because I hard-coded it into the script to use something else. Like, I'm not using the implicit directory thing, I'm actually overwriting it. Yeah, actually, yeah. Where did you run this? You CD it into scripts and then you did it. Oh, yeah, the BYFN part. Do you know where you ran that from?
This the network is
Yeah.
there's supposed to be.
That's the directory.
Then there is created a network with that Docker version. Means that
I've got 1.30.
1.30.
And the API version is 1.26.
Let me double check what I have. Can you also run Docker version? You have a 10.09 and then you have 10.06.
Mine is, wait a second. Okay. Mine is, I mean, it's, they changed the version schema, I think last year.
Yeah.
Mine is 18.
Mine is also 18. If you have to update them, that's going to be. But I think you might have to. That might be the problem.
I think probably. I mean, or they could just create a Docker network. Doesn't work. If you manually create a Docker.
I think the containers have the containers
Or
that
they probably should change the script.
Yeah.
Yeah. Where is it? I'm gonna put the Docker version in the prerequisite. You remember where you specify the Docker?
I think it's in the compose file somewhere. Oh no, you're right. Okay, I make it through the EDM workshop based on the GUR, and then it the containers will look for _BYFN, and you have to set. Yeah, I have to change it so it expects the EDM workshop. _BYFN. So we have to figure out how does the old Docker create networks when we do Docker compose.
Can we just?
But I don't. So you're saying this is a networking problem?
It's not a networking, it's like an API change from the way Docker used to.
Create the network under the name scheme.
Okay, so if you have the network issue, I think your problem's different, right?
Let's try to create. We should be able to manually create a network.
Are you looking at the
Yeah, okay.
volume names?
No, the network name. So we have people around the network.
And I'm having a problem with the volume names.
Yes, yeah.
But so that's not the same as people.
Let's see if we can at least have a network. Let's try to create a network. Docker networks to create. Do we need to join or take?
Yeah.
And that was a dash, and that's where you get the Docker and we create a something.
Yeah, we thought this must be a Docker purpose. We're just trying to figure out
If we
how
can
to
do
solve
it
that issue
the
without
older-
operating.
Wait, I'm doing it, trying to do it.
Can we try it again? And I'm not really sure. Can we? Instantiate. Okay, can you see Docker PS?
Oh, yeah, we haven't gotten to that stage. We're at instantiation.
Okay, I think that I'm not really a Docker expert, but the easiest thing to do is to operate Docker.
Docker network. I'm just trying to verify.
I mean, this is basically post the old Docker network under the name schema, which is different from
Does that work if you just create the thing? They have to be connected.
yeah.
Can we rename?
Let's take.
I'm just going to look up. So we're going to create the network that you need, and then we're going to try to switch the container to the network.
Oh, you can Docker network connect. You just connect container to the network.
Or if they're willing to BYF them down, I can just change the script. So that way they use the one that they already have. That's easier. Okay. BYFN down the network. BYFN
Can we just change the network name expected?
Because I'm on a different tutorial with Indy, and I'm going to have to leave today. But I'm really keen to understand how to run EDM on Fabric. Is there any? I was searching for a tutorial on the schedule, but I haven't seen one. Can you point me to the materials that you were using on today's tutorial?
We just uploaded.
Oh, you just have.
Yes.
Okay, so it's there.
Yeah, it's there now.
You're from IBM.
Yeah.
Open Technologies.
Oh yes. Okay.
Is there any way we can contact you to, because you guys are basically responsible for working towards it.
And you want to have email, rocket chat, or something, whatever.
I'm from IBM as well. It's just
a matter of. I could give you my email or.
You're
which
Jay.
one? What? Jay.
You're Jay. I'm going to contact you back because I have a couple of questions about a potential portability of an ERC20 token created on Fabric, which this is the 50th time. That is just like traditional Ethereum
So the slides have been posted to the session, but the session is like weird because they, on the schedule, right, it has it like in multiple places. So the very first instance of it in the morning has the slides on it.
more reasonable.
It'll show up
Since
like right
EVM is
here.
already available.
So if you go back
Would
to the
be,
schedule.
very easy to create a token on Fabric, do the KYC process, and then just burn it and reissue it on Ethereum.
Oh, okay.
But on
Okay.
the
So,
after,
I mean, on your, hopefully on the, online, because these people, we've gotten them to download it from there, so it should be online. Yeah. And we're also running the workshop tomorrow. too.
Yeah, we hopefully can have people.
No, you're fine.
Gambling those tokens.
very nice. Thank you very much.
Okay, so the people who are dealing with the network problem, sorry, I made you guys open the wrong file. Open up the byfn.sh script file. In there, there's line 34. You should see an export compose project name. You're going to change it so it does EVM workshop, no dash. byfn.sh. I can open it up. And then line 34. So it should be at the top under all the comments. You're going to change that. You're going to get rid of the dash here.
It's only for people running an old market.
Yeah. Oh, yeah. This is only for people who are using a Docker version that's in the old schema, 110, 1 something like that. If you're in Docker version 18 point something, you don't have to do any of this. And then once you've done that, bring your network back up. You might have to run the generate again, and then we'll see.
Including generate.